Hi everybody and welcome to another exciting edition of Boring JavaScript. I'm your host, the Virtuoid, aka Mike Smith, and today we're taking a look at mutation observers. What is a mutation observer? Well, it's exactly what the name implies. It observes mutations. Specifically, if a particular DOM element mutates in some way, whether it's a child or a subtree within the child or an attribute, as long as something changes within that element, the mutation observer will throw up an event and warn you that, hey, something's gone on, you may need to check on it. So for example, suppose you had a table and somebody somewhere inserted a new row into your table. If you had a mutation observer on your t-body of the table, that mutation observer will suddenly say, I've got a new row here, I better let the program know. So it throws up a mutation observer event and says, hey, you got a new row, you may want to do something about it. And that's what mutation observers do. Really wonderful to use, really powerful. You want to see how it works? Let's get started. So let's take a look at a quick example of how to use a mutation observer. First of all, I have a table here. It's a table listing of all my animals in the zoo, and I have a button here that every time I click on it, I want to add an animal. No big deal there. Let's take a look at our JavaScript. JavaScript is also extremely simple. Basically, I have a fetch statement here to fetch my JSON file. My JSON file has 100 different animals in it. And once it finishes up, it enables our add button. And our add button, when we have a click event, will execute our add animal method, which just very simply just sits, just very simply gets an animal index, a random animal out of the JSON file. There's 100 different animals in there. Constructs a TR line and inserts it into the T-body. I mean, that's it. Nothing really special. Let's take a look at what it looks like on the browser. I'm going to do a Control F5 and refresh it. I'm going to click on Add Animal. And there's Karen, there's George, there's Ichthy, there's Yvonne, there's Darlene, there's On the Wall fly. Anyway, so real simple. Your boss comes to you and says, well, once you click on Add Animal, how do you know which animal is added? And you say, well, that's no big deal. I've got it right here. So everybody's fat and happy. Well, your boss comes to you a little later on and says, I got this third party who has this routine to add animals for us, and all we have to do is supply them with a element or an object that points to our T-body element. And you say, well, no, we don't really need it. But the boss says, yeah, we do. So I want you to add it in. Well, you add it in. Let's take a look at the code. And through the magic of television, this is the new code. We still have all of our fetching, we still have all of our add animal, we still have our add animal routine itself, but now we're calling a routine called bad third party add animal. And this represents the really bad third party code. So basically I'm passing it my T-body, which is the pointer element to the body of my table, and it randomizes, or it gets the random animal and it constructs the TR and it adds it to the element, just like our routine did. So you run the code. Let's flip over to the browser. Let's do a Control F5 to refresh. We click on Add Animal, and yep, there's Fido, there's Fishy, there's Ollie, there's Shepherd, there's Olivia, there's Donald. Donald Duck, yay! And so, yeah, it works great. It works fine. Your boss comes to you and say, well, how do you know which animal got added to our list? You go back and say, well, honestly, I don't know, because bad third-party animal doesn't tell me what it's actually added. So I guess what I can do, I know it adds it at the very end each and every time. So I'll just parse out T-body after I call bad third-party add animal. I'll parse out T-body and get the last TR. That way I know what animal got added. Your boss is happy with that, and everybody goes off. About 6 months later, bad third-party add animal decided to change their routine. Let's take a look at it now. And through the magic of television, this is their routine. It is now called really bad third-party add animal, because not only now does it sit there and figure out what animal to add and construct the row that's going to add, but it then also randomizes what row it's going to put it in. So it's not always at the end of the table. It is now sometimes at the end, sometimes in the middle, maybe at the top. Well, actually, the way the code's written here, it'd never be at the top, but it could be next to the top. It could be just about anywhere on there. So you go over to the browser, you run the browser over here. Let's Control F5 first. We add an animal. Yep, there's Wilbur, and then there's Archie. That got at the end. Jerry got added to the second row. And Bobby was the new one there. It got added to the second row. And there's Ignatius. It got added as the third row. And okay, I guess that'd be, yeah, was this Harriet or Bobby? I've lost track which one it is now. Well, doesn't matter. Problem is here is I got real confused about what row or what animal was added to the row. So your boss comes to you again and says, well, what animal got added? And you can say, I don't know. Well, I guess what I could do is I can get a snapshot of the table just before I call really bad third-party animal and a snapshot of the table after I call real bad third-party animal and compare the two and figure out what row got added. Yeah, that'll work until you have about 10,000 animals. And then, good Lord, what's going to happen? But mutation observers can help with that. I'll show you that next. So let's add some code that shows you how a mutation observer will help you with that situation. And once again, through the magic of television, I still have my add animal and I still have my really bad third-party add animal routine. Again, what am I going to do? Mutation observer is the answer. So again, a mutation observer, you attach it to a particular node and it will observe that node. And when something mutates on that node, whether it could be, an attribute or a child node or something like that, it will inform you through an event that something has occurred. So how does that work? Well, let's go back to our fetch section here. Now the fetch section before, we fetched our JSON file, we turned it into a JSON file, and then we saved the data. But now we've added a couple of extra lines here. We've added what's called a table observer. This is how you add a new mutation observer by calling, of course, new mutation observer. And you pass it one argument, and that is the callback argument. And that callback argument is the routine that you're going to call when that event fires. And we'll take a look at that here in a second. Now that just actually sets everything up, but it doesn't turn on anything. To actually turn on something, you need to observe. And that usually takes two arguments. The first argument to the observe method, and this observe method is on our observer, our mutation observer itself that we just created. The first argument is the element that we're observing. And in this case, we're observing the t-body. So anything that changes within the t-body, we're going to check on, right? Well, no, not right. If you did that, it can really slow down your computer if you have a lot of mutation observers. So you want to try to be as specific as possible. And that's what the second argument is all about. This is the different things you can check. You can check, for example, the child list is what we're doing here. And that basically says that if any child changes within that child, within the t-body, a child is added or a child is subtracted, then it will fire off the event. There's other parameters we can put in, like for instance, if the content of the t-body has changed, or if an attribute of the t-body has changed. You can go to the Mozilla Developer Network and it will tell you all the different events that we can listen for. In this particular case, just to kind of show you how it works, I'm going to do the child list, which will basically say, hey, if something happens on the child itself, in this case, adding a new node, I want you to fire an event. When that event is fired, it's going to call this added a new animal method. And that's what this is up here. So there's our event. And first of all, it returns a lot of information. The first big piece of information is the type of event. If you're looking for different types of methods, the first thing you would do is check, see if event.type equals whatever. In this case, mine will always equal childless because that's all I'm checking for. So in this case here, I am doing, I'm taking a look to find out if any nodes have been added. And if one node has been added, then I grab the inner text of that node and then I save it to a routine, to another DOM node that I'll show you here in just a second. But the key here is that this mutation observer has noticed that I have added a new node, and it has in particular an add nodes property that gives me an array of all the nodes that have been added. So if I added multiple TRs, multiple animals, it will tell me that. If I added just one animal, it will tell me that. There's also removed, no, I think it's called removed nodes. There's a removed nodes property that says if I've removed any particular nodes. So this event contains a mutation event contains a great deal of information to help you with what is actually changed within the t-body. Now in our case, since we are just working with child list, I'm not even checking the event.type. All I'm doing here is I'm just grabbing that node that got added and I'm grabbing the inner text, which is an old way of doing it, but it looked best on the output. And so all I did here on the index.html is I added a little animal added P here so I can output what actual animal got added. So that's it. That's all there really is to it. None of this up here has changed. That's all exactly the same. The big key here is I've added the new mutation observer and told it what callback to use, and I told it what to observe. Now once I'm done, there's actually an unobserved too that will remove this observation. I'm not doing that in this case, but just be aware that you'll need to do that or you'll start having memory leaks and Lord knows what else happens in that case. So, and then all you have to do inside of your added new animal or your callback routine is to do whatever you need to do. In this case, I'm just typing in onto my HTML what animal got added. So let's take a look at it and see how that works. Let's flip over to our browser. Let's do a Control F5. We click on Add Animal. Yep, it found Paul Puma, which basically means as soon as it saw that TR get put in there, it threw in that it threw that mutation observer event, and it called added a new animal. Added a new animal figured out based upon the added nodes property that we've added Paul Puma. I click on that again. There's Fred Fox. As you can see, we have added Fred Fox. And then Moby Dick the Whale has been added. Notice it was not added at the end. It was added in the middle again because this routine adds it anywhere. But I don't care where it adds it now because I know exactly what node got added. So no matter how many times I click that, there's Yvonne, there's Quick the Quetzal, there's Bob the Badger, there's Darlene the Dixie Poo, there's Mary the Manatee, and so on, and Frida the Frog, so on and so forth. So now I don't care where this really bad third-party routine puts this new animal. I know where it put it because I've got a mutation observer on it. And that's all there is to mutation observers. I hope you enjoyed our video. Hope I didn't bore you to death. Please make sure you click on the like button below and click on the subscribe button to subscribe to this channel. Also, you can see everything that we've done at www.boringjavascript.com. Thanks again for watching, and we'll see you later.